You're tuned in to the Data Masters podcast. In each episode, we dissect the complexities of data management and discuss the data strategies that fuel innovation, growth, and efficiency. We speak with industry leaders who share how their modern approaches to data management help their organizations succeed. Let's dive straight into today's episode with Anthony Dayton.
Welcome back to Data Masters. Today, we're digging into a term that's absolutely everywhere, but often misunderstood: the semantic layer. What is it really, and why has it become so critical to both the future of BI and AI? To help us cut through the noise, we're joined by a true pioneer in this space. Our guest is David Mariani, the co-founder and CTO at AtScale. With a background in building massive analytic platforms at places like Yahoo, David leads the charge in creating a universal semantic layer for some of the biggest companies in the world. And he's here to give us a masterclass on what a semantic layer is, what it isn't, and why it's the key to unlocking trusted AI-ready data. David, welcome to the show.
Thanks for having me, Anthony.
So, as I suggested in the introduction, this idea of a semantic layer is everywhere, but it's a little bit like one of these things. And I ask people, out on the street, "What's a semantic layer to you?" Everybody's got their own picture of what a semantic layer is, and so I think it would be really helpful to ground the conversation if you can put a stake in the ground. And literally, I can't think of anyone better in the world to do this. Like, what is a semantic layer and what problem does it solve?
Yeah, well, let's start with just a history lesson first, Anthony. So, semantic layers have been around since probably business intelligence has been around. The difference today versus then is that the semantic layer has traditionally lived in the consumption layer, in the BI tool. And so it's been a core part of not just the metadata and the business, the logical view of that data, but it's also been really tightly knit with the presentation layer, with the visualization layer. And some people have looked at building semantic layers in the data platform itself, in the database, and that took the form of things like schemas, like you hear a lot of people talking about the medallion architecture, so they're creating reporting views or stored procedures and the like. And so I've experienced the semantic layers in both sort of places during my career. And it was really at Yahoo where I really saw it in spades. And that was because Yahoo was born as a business unit focused organization where the business units owned their own stacks. And so because of that, we had one of everything. And because of that, we had multiple semantic layers. And the issue that I had there was that, the basic measures of the business, which are basically clicks and page views, everybody had a different definition of it. Because some people were using MicroStrategy, that had a semantic layer. Some people were using Tableau, that had a semantic layer. Some people were using ClickView, that had a semantic layer. And so at the end of the day, nobody could really mesh those numbers together. So Yahoo Finance's numbers were not comparable to Yahoo Sports or to Yahoo Front Page. And when it came to revenue, search and display, couldn't compare their numbers because we couldn't agree upon the very basic fundamental metrics of the business. So what really came to me at that point is for the semantic layer truly to be the single source of truth, it needed to live independent of the consumption layer and the data platform layer. Because just like we had multiple consumption tools at Yahoo, we also had multiple data platforms because most of our data was in Oracle, but moving to this new thing we called Hadoop, which was the data lake. And so there wasn't a single place to store your data. So the universal semantic layer is something that we invented at AtScale. And the idea there was to create a single source of truth, a logical representation of your data. So you ask about what it is. First of all, it's virtualized. So the semantic layer is not a data store. We don't ingest data into a semantic layer. It is really a router, a logical data router where we can present a logical view to the consumption tools, which include BI and AI, and then translate those logical business queries into physical SQL queries that we can run against the data platforms. And while we're doing that, we're learning about the data, we're learning about patterns, and we're optimizing it. So we're creating aggregates in the data platform to make those queries faster so that customers can avoid having to create data extracts or to create import modes where they're actually creating copies of data for analytics. So really, that's it. A semantic layer needs to be universal. It needs to be virtualized so it doesn't store data or create yet another sort of data stack. And it's got to be and it's got to scale to handle the most complex business use cases, so that people can model their business in the semantic layer without having to resort to building that logic in the front end.
So I think that's helpful. And let me add maybe a layer to it. And I think the trick is in the word semantic. So tell me if you would agree with this, which is that a semantic layer is a way for businesses to describe the meaning of their data. You make these important points that it follows, therefore, that it shouldn't be stored in the data layer. It shouldn't be stored in the presentation layer. It needs, all of the points you made previously. But the problem that the semantic layer solves is giving language to data, which almost by definition is sort of language independent, and giving a way for business people to talk about their data. Is that a fair summary? I don't want to put words in your mouth, but
It really is. And you know what? It's a little bit, when it comes to business intelligence, the semantic layer sort of manifests itself through measures and dimensions in those BI tools where people are dragging and dropping and double clicking to drill down. But really, it's really an AI that's really sort of made it more obvious, because what does an LLM need? An LLM needs business context. It needs context about your business, because LLMs are trained on the general internet. They don't understand what Tamer's ARR means, or how you calculate your ARR, or what you call gross margin, or what you call a customer. That is definitely something that has been defined for your business. So when you marry universal semantic layer, which brings context and brings that detailed information about your business, with the power of an LLM, magic happens. And it happens because an LLM is so much more powerful than a sort of traditional BI tool where you're forcing the human to sort of find the patterns in the data versus relying on LLMs to navigate that for you using business context and
right. And
semantics.
using, again, the trick is in the words, but it's using the language. But let's come back to the AI story in a second, because I want to go back in your introduction. And I just want to be careful and clear about differentiating between two different other alternatives. So a not unreasonable perspective that someone might bring to this conversation is to say, wouldn't it be best to contain my semantic layer in my data preparation experience? And so, or said differently, in the act of preparing my data, heaven forbid in a spreadsheet, it is in that mode, in that moment, that I will be giving it meaning and language and and actually, I suppose in a way the spreadsheet example is a perfect one, because you can label columns and rows anything you like in a spreadsheet. But imagine for the moment, a not unreasonable perspective is data preparation as a mechanism of creating semantics. Um, uh, I imagine you think that's a terrible idea, but give language to
Well,
why it's a terrible idea.
let's talk about that because look, when it comes to data prep, first of all, the semantic layer is virtual, right? And so it needs to talk to the physical. And I like to think I like to separate that logical from the physical, but the physical, that data needs to get into shape and needs to be queryable and needs to have quality. And really the semantic, that's not the role of the semantic layer. So if you talk about and you think about the medallion architecture, where you have bronze, which is the raw data, you have silver, which has been, which has been cleaned, and then you have what they call the gold layer. And the gold layer traditionally is those reporting views. And what I see customers doing is that the semantic layer can either take the place of the gold layer or it can sit on top of the gold layer. And it doesn't matter, honestly, because, but what I find is like for customers who don't have a semantic layer and are trying to use the gold layer as their data API, the problem is that the business wants to combine that in different fashions, in different ways. And so if you're thinking about it, it goes back to IT trying to keep up with the pace of the business where new things are happening all the time. And that's sort of like, let me like physically store the data you want, Mr. Business Customer, who doesn't understand the business. It's better to put the business logic in the hands of the business, allow them to use that virtual semantic layer to then combine and define additional sort of virtual metrics and dimensions in a way that makes sense to the business. It just allows the IT and the data engineers to do their job really well, put data in a form that can be consumed by the semantic layer, and it gives business the power of creating their own data products, Anthony. So I think it's a very, very complementary. One cannot exist without the other.
So I think that makes a ton of sense. And maybe to add to that, the confusion when people think about a semantic layer as data prep is that you're really just pushing the two ideas into one. You're saying the data is the semantic layer. And I think where you started is exactly right. The language you use to describe the data is by its nature different than the data. And you use the example of defining what is a customer, or in your Yahoo example, what is a click. The idea of a click versus the actual records that comprise a click. The records themselves may be in multiple databases. They may be described in very different ways than the language. But that does sort of beg an alternative, which I'll throw to you, which is, well, maybe this should all be described in the consumption tool, in the BI tool, or again, God forbid, the spreadsheet, but more likely the BI tool. And you've made this point, but I want to give you the opportunity to help listeners be really crisp with why defining the semantic layer in Power BI, Click, Tableau, ThoughtSpot, whatever, is a terrible idea.
So on a couple fronts of why it's a bad idea. Now, if you only have one tool that you consume data with, and I now that AI is here and GenAI is here, I don't think anybody can say that that's affirmative anymore. Now, you could say before AI that, yeah, you know what, I'm a Power BI shop and that's all I'm going to use, except there's also Excel. But Power BI can serve that too. So I guess, Anthony, if you have more than one, then you're going to have more than one definition of your business metrics. If you have more than one consumption tool, and I would argue that today you definitely have at least two: your BI platform and now your AI chatbot, AI agent, whatever you want to use.
But I actually don't even think you need that to be true, which is, even let's just imagine a world where everybody's standardized on Power BI. Then you still have multiple Power BI workbooks.
That's exactly right. And you're right. So you have the balkanization within the tool itself, because they're not made to be objects are not made to be shared there or to be consumed and across different analytics. Thank you for making that point. So that's one problem, one dimension of the problem. The other dimension of the problem, and I see this in customers all the time, is lock-in. So we don't know what's going to come up, and we don't know what the new sort of consumption pattern will be. And people may be talking to their data. Maybe we have headless agents that are not even they're just machines that are taking action on data. We don't know. And so to make a bet where you're saying, I'm going to put my semantics in this BI tool or this tool, or even if I'm going to make a bet to put it into a data platform of this type, which is what, by the way, Snowflake and Databricks are trying to make you do, it's like that locks you in. And so what I would say there, they call it shifting left. It's like, okay, that's great, except that why is everybody investing in Iceberg? They're investing in Iceberg as their data format because they want to have the freedom of choosing the best engine to operate on that data. So if you're going to go ahead and build your semantic layer in the data platform, now you're stuck there as well. And as you know, if you're going to invest in Iceberg as a general data format because you want that freedom to move to the lowest cost provider, well, that's now become an impediment if all your semantics are now talking to something that's going to be really hard to undo. So that's why I like so that's the second dimension, Anthony. It's not just that you don't have a single source of truth because you have multiple consumers of that data, but you also you can't future proof your business because you've embedded your most important meaning about your business in the data platform or in the consumption tool.
Got it. And of course, it's in their strong interest to have you do that. So, and I want to come back to this idea of open, but I just want to kind of wrap up a little bit in a bow where we've gotten to. So semantic layer is about, it's about the language you're using to describe the data. It's a business language for describing the meaning of the metrics and dimensions that drive your business. It needs to be independent of the consumption tool, independent of the data storage layer, and it needs to be so that it can be that you can have flexibility in those underlying tools, but also that those underlying tools themselves have a lot of complexity that you don't want burdened with this. Now, you mentioned this point about lock-in, vendor lock-in, and a commitment to flexibility and openness. And I know AtScale in particular has made some big investments here with SML. Everything needs a 3-letter acronym. So you've appropriately gone on the 3-letter acronym bandwagon. Congrats. But I guarantee that no one listening to this has any idea what SML is. So why don't you start us off with what is SML, and then we can talk about why it's important.
Well, so it stands for semantic modeling language. Okay, so
very logical.
So if you so I've just been talking about vendor lock-in, right? Well, what about AtScale, right? What about if you don't want to lock yourself into a single semantic layer either, because then you have the same problem of if a better tool comes up or a lower cost tool comes up, now you got to rewire everything from your semantic layer. So I can't talk in both sides of my mouth, right? I can't say don't go for lock-in on the BI tool, don't go for lock-in the data platform. So we invented SML and we open sourced it, Anthony, so that and we're pushing it as a standard language for describing semantics and semantic models. And we made it object-oriented. We made it YAML-based, so it's very standards, and it's very standard. It's composable, which is really important in today's sort of world where you want the business units to be able to create their own semantic models. Hey, we want LLMs and AI to create their own semantic models. So it's got to be composable for humans and machines. And so we did that, and we created it as a standard and open sourced it. because we want SML to be the common language that semantic layers can implement at their foundational level. So, and before it gets out of hand. So look, we were the first to do a universal semantic layer. Now there's a lot of different semantic layer providers out there, including some big boys out there. And I don't know if this just recently came to press where Snowflake announced their initiative of OSI, which is their sort of open interchange for semantics. And it is it's not a semantic modeling language. It's a way to move from one proprietary semantic modeling language to another. That's like, just imagine, Anthony, if there was no SQL, there was no structured query language, but you had a query language interchange. And so everybody could keep their own sort of query languages. And then if you wanted to go from SQL Server to Oracle, you had to then use this migration tool to migrate all your code to this new language. That doesn't make any sense to me. It's like, it was really important that SQL became a standard that the database vendors implemented. It created a whole data and analytics ecosystem around that and it really created some great possibilities. So we think that somebody had to do it. Nobody was doing it. So we had to go ahead and say, you know what, we're just going to open source this. And hopefully, the rest of the players will sign on, and we'll make it so that now the semantic layer won't have lock-in.
And I think that's great. And I very much appreciate or acknowledge the point you're making about talking on both sides of your mouth. I think the argument here, of course, is that you can create the standard, but then also be the best player within that standard. But, maybe there's some innovation that occurs on the edges that's really, useful and interesting and exciting and helps advance the cause. Obviously, one area of innovation and excitement, and we've already brought this up, is large language models and AI. And a little to the earlier commentary, the nature of a semantic layer is that it's language. It's using words to describe the data. And I think this is you made this point earlier, just to bring it back to the front of the conversation, that large language models by their nature don't understand, are not actually very good with data. They're actually very poor with calculations. They're not even particularly good with data. And they don't know anything about your business. They've been trained on the public internet, as you described. But talk us through this in a bit more detail, the connection between databases, data, the semantic layer, AI, and maybe even BI. And actually, just to be controversial for a minute, is it your view that the predominant consumption experience will be through these AI large language model interfaces?
Yes. But and I'll just describe my experience so far. It's my mind has been blown, and it's changed everything. As a leader of product at AtScale, I actually rewrote my whole product roadmap after having some experience with these tools in combination with the semantic layer. But let's just talk about, there's two parts where the semantic layer really helps GenAI. The first one is the metadata, and most people just think about the metadata. You're right, Anthony, it is about the language and the business language overlay on top of the physical data. But the other really important part is the query engine itself that comes with the semantic layer. And why is that important? You just mentioned it. You said that LLMs are not really good at doing calculations, for example, or navigating joins and the like, and doing that in a deterministic fashion.
Right.
So what the semantic layer does is it makes the job for the LLM really easy. Because what we do, the way we do it is that a model gets presented to the LLM as a single table. So you may have 250 metrics and 100 different dimensions and all these different hierarchies, but to the LLM, it's a single logical table, which means there are no joins that are necessary. So it's the semantic layer that generates the SQL that does all those nasty joins, whether it's a many to many, or it's semi-additive or non-additive, or you have to do a calculation that requires multiple passes of the data. All those things are really hard for an LLM to do on its own. So it's really the combination of providing the language context to the LLM, and then providing also a very easy interface so that the LLM can generate very basic logical SQL. And then the semantic engine can take care of all the nastiness of translating that into the physical queries against the respective data platforms.
So let me pause you there for a second, because I think that may be something new for listeners. There's certainly a school of thought out there that what large language models need is a text to SQL engine, that will solve the problem. It sounds like you wouldn't agree with that, or at least you would say that's the wrong path to solving this problem. That better to give it a good semantic model. Is that fair?
Yeah, and we did tests with and without a semantic model. So to give credit where credit's due, Juan Cicada of data.world is, which I think is now part of ServiceNow, I think. He did the original benchmark where he compared an LLM on a semantic layer versus an LLM by itself. And it was pretty stark in terms of how much a semantic layer helped. So we took that same research, but we did it against TPC-DS. Because TPC-DS, it's a more complicated schema. It's a retail-based model. It comes with predefined queries. So it's a little bit, it's a little more standardized. And when we ran it with a semantic layer on AtScale versus just raw, the LLM was wrong 80% of the time, Anthony, without a semantic layer. It got 20% of the answers right. And it wasn't just that, because LLMs had to do the joins and had to do all that navigation and calculations on their own, the answers were not deterministic.
Oh, so one day you'd ask the question to get 3, and the next day you ask it to get 5.
Exactly. And then that's really, really scary, because the way that these LLMs, they're so confident in terms of their answers. And they give users false confidence, and that could change from day to day or query to query. So the value of the semantic engine is that those queries will always be deterministic, because the semantic model has already defined those paths, and those paths don't change. What does change is that text to SQL, for which that metadata is really important for the LLM. So now if you combine those two together, you combine the semantic layer and the LLM, and what we found is that we used Model Context Protocol, or MCP, as that interface, and it's lights out, Anthony. So now if you use MCP as a protocol, now that LLM is talking straight to the semantic layer with no extra work, no training, no nothing. And so back to your original question, what's going to be the future of consumption? I've been using just Claude as a chatbot, and a lot of people think of natural language query. They'll first start with, and I started this in doing my demos, like, okay, show me sales by product for Canada for 2002. And it's like, okay. And then somebody else came to me and said, David, why would you do that? You're acting like a BI tool now.
Right.
Or you can imagine I was just automating the clicks, right? And the drags and drops.
What you would have done through the UI of a BI
That's
tool.
what I would have done. And instead he says, show me insights on sales. And the LLM will then go, and it wrote, 10, 15 queries against the semantic layer, and came up with all these insights, and then even charted them and created a dashboard for me. I didn't ask for any of that. I just said, show me insights on sales. And to me, that was like, okay, we're thinking about this the wrong way. The future of using these LLMs is to let the LLM do the needle in the haystack for you, not to the traditional way where let's click and drag and drop as fast as we can, because we need to ask a million questions to get to something that's actually a valuable answer. And that blew my mind. And so I do think things will definitely change in terms of how people consume analytics. I still don't know whether that's a chatbot or that's something else, Anthony, but I definitely know that it's an LLM paired with a semantic layer, and probably through MCP as a really good interface to make those LLMs really smart.
Interesting. Yeah, no, I think that, or I might refine what you said slightly, which is to say that the idea of an LLM using a semantic layer in the context of trying to create queries on data, because there are lots of things LLMs can do that aren't about querying data. And I think there's another really important insight that you draw there, which is the tendency for us to come at the problem as though we were clicking around, especially people like us, as though we were clicking around in a BI tool, when what business users do is just ask questions about the business, not about the data. The problem that we're talking about solving here is translating the business question into a data question, which traditionally you would have given to a data team and said, okay, data team, like figure out the data question that comes from this business question, which actually brings me to a sort of in a funny way, in a roundabout way, brings me to a harder question, which is who should own the semantic layer? So imagine someone's listening to this podcast and like, this all sounds great. We need a semantic layer. I need to go do it. Um, should they be a data person? Should they be business leader? Should they be, if they are a data person, are they the, the report writer type, or are they the data engineer type writing Python code? Like, who's the ideal owner of this layer, so to speak?
So yes. So what I would say is that it's like what I would do with AtScale at Yahoo is that I definitely, so there's participation from the data engineers. To me, the data engineers would create the base semantic objects. In SML, it's called a data set. A data set is a representation. It can be a straight map to a table, or it could be a query, or it could be a table with calculated columns. So if I were doing it, I would have my data engineers go a little bit further on their pipeline. So they wouldn't just write the tables. They'd also write some base semantic objects, and they would include that into a repository. So with SML, it's code, and with AtScale Design Center, AtScale's, you store all of the SML in Git, and you can have multiple repositories. So what I would then do is that I would put those into a common repository. And then what I would do is I'd open that up to the business. So each business unit could have their own Git repos, and they could create their own semantic objects and own semantic models. And they could refer to those base objects. And those base objects are not just data sets. They could be base dimensions, like the calendar. Very important in a retail is to have a common calendar that you're reporting on, that you're using with time. It's really important to have a common product dimension, a common organization dimension. You can imagine that those are curated maybe by a central team, maybe by a team that's anointed with that duty, or maybe a business unit that is designated as the owner. But it needs to be distributed, Anthony, is the short answer to my long answer. It should be distributed in a semantic layer that's composable and is backed by code, makes that possible so that you can decentralize your data product creation without creating chaos and creating mistrust in the data because you've lost your single source of truth. So semantic objects should be also controlled, just like source code is controlled. So if somebody wants to contribute a new base object, it should be a pull request. And that pull request should be reviewed by somebody who is designated as that reviewer for that particular repository. And they can decide to accept it or ask for changes or reject it, because there could be another semantic object that's similar or a duplicate. So I really think of semantics and semantic layers should be a software sort of CI/CD kind of a practice. And if you do that, I think you can open up data product creation and move it to the edges without getting into the problems of the past, where you have everybody rolling their own when it comes to analytics and business definitions.
It's a very nice way of describing it. The semantic layer is a software asset, because I think it also helps encapsulate why it's so different than the underlying data. So one of the obvious sort of parallels and overlaps here between, the work that Tamer does and that you're doing, is thinking about giving people access to clean, curated, up-to-date data. Well, there are two problems there. One is a language to describe that data. Like, what are we talking about? Are we talking about retail sales? Or are we talking about farm animals, or whatever the other, whatever it is? And then the second is the actual underlying data. Like, where are the sales, and, what kind of animals are we talking about? Like, it's that next level down that we think a lot about. And you're thinking about the language to describe it, the software asset over the hardware substrate, if you want to think of it that way. So
Yeah, Anthony,
please.
before we leave this, I want to go. You piqued my another sort of question I had, or a comment I had, which is that when we're talking about LLMs, I want to make sure that your listeners don't just think of LLMs from a query perspective. So because LLMs are really good at writing code. And you asked about, okay, who creates the semantic layer? Who creates the semantic model? Guess what? AI and LLMs are going to create the semantic models. So what we're really investing in now, and we're doing it through MCP because we can create tools. I can create a measure tool, a dimension tool, a calculation tool, a semantic model tool that then take all those three elements and create models from your data. So what we're investing in is going beyond just using the LLM to query a semantic layer, but also using the LLM to create the semantic model itself.
Interesting.
And you can imagine, right, that this could be self-learning. So as people ask questions, we can see a pattern in those questions, and potentially create new semantic objects that are pre-built to answer the questions that maybe those users are taking a haphazard path to get to.
So but to play with that idea for a second, and tell me if you agree with the way I'm framing this. The point you're making is that the kinds of language and questions that people ask of the business, and I'm being careful not to say anything about data, the things they're asking about the business change as the strategic environment of the business changes. And again, to put words in your mouth, the semantic layer needs to keep up. It needs to be prepared to answer the questions that are coming. Did I get it?
You got it. And right today, semantics, the hardest part of implementing a semantic layer is building the semantic models. And so today it's far too human curated. And so we've been investing in a chatbot, in a copilot that uses an LLMs through MCP, and allows the human still has to approve it. The human still has to look and see what the LLM is generating. Just like you wouldn't trust an LLM to write your JavaScript without reviewing it. But it's going to be much easier because that's part of the barrier to getting value out of a semantic layer. Is it needs a semantic models to generate that value and that ROI. And so I think that in the very near future, you're going to see many more machine generated semantic models with humans curating and human oversight.
Interesting. Well, again, not to draw the parallel with Tamer too directly, but that sounds very similar conceptually to the way we talk about not the semantic layer, but the data itself, right? Because, fundamentally, when you have duplicate data records, like, the model can be helpful and human feedback is important. I was going to ask you about the future of the semantic layer, but you've sort of gotten there yourself. I think this vision you're setting out of it's AI out and AI in is really compelling.
Yes, that's exactly right. That's well said. And I think that one of the things that was always a challenge for us as a semantic layer platform company is that in the BI tools, right, there's a lot of client side calculations. And a lot of times we've gotten a lot of questions like, well, how can I turn those client side calculations? I don't want them to be defined in the client. They should be defined in the semantic layer. And it was always like, man, if I try to do that, I'm going to be presenting that semantic modeler with a bunch of noise. I could use AI to just surface the ones that matter. And I don't even, with the right kind of rules, I could actually create the semantic and enhance the semantic model, in place through users
AI is so good at
interacting with it.
summarizing long form text. Here you're asking it to summarize complex calculations.
Mhm. So I'm really excited about it. I think there's so much more to be done. I was talking to a customer this morning, and they have a knowledge graph tool, and they have AtScale, and they're like, okay, how can we make the knowledge graph tool and AtScale work together? And my answer was that they wanted to use it for AI because they have people that are asking questions, or customers are asking questions about particular prescriptions or ailments and the like. And it's like, and they have a knowledge graph with all these terms in it. And it's like, well, the answer is like, use MCP. So you have MCP on top of your knowledge graph. You have MCP on top of your semantic layer. The LLM has access to both of those, and let the LLM do the mashing. Let the LLM you're just informing the LLM. You're giving it more data about your business, and that data can come from any form, not just a semantic layer.
Yeah, no, I love it. I think that's and it's a good way of thinking about the problem, because it's a separation of concerns. So, well, David, thank you for the time. I hope that for listeners, we've demystified the semantic layer. It certainly has for me, and hopefully people have a better sense for what it is, why it's valuable, and how one should go about thinking about implementing one. So, thank you for the time.
Thanks, Anthony. Appreciate it.
Thanks for joining us for the latest episode of the Data Masters podcast. You'll find links in the show notes to any resources mentioned on today's show. And if you're enjoying our podcast, please subscribe so you never miss an episode.